Hello. We're starting our new Unit 8 on Trig Identities. Lesson number 1 is do not get behind. Do not wait until the day before a quiz to start studying. Do not do these at midnight. Practice, 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 and then practice some more. Okay? Trig Identities are a puzzle in logic. We use them in calculus to simplify integrals before we can integrate. All right, so that's the reason you need to know them. This worksheet, the other math teachers love. It's sort of a way to practice solving a problem one step at a time. The only one I know how to do is the first one. The trick is we're going to try and change the word boy to the word man by only changing one letter at a time. So I start out with boy. And then I'm going to change that O to an A. And it still has to be a word. It says bay. Then I'm going to change the Y to an N, and I now have ban. And then I'm going to change the B to an M, and I have man. Okay, so I switched a boy to a man, and I was done. The rest of them, I don't know how to do. You can do them. They're fun, apparently, but I don't know how to do them. All right, so we're going to talk about trig identities. These you need to memorize, okay? That M word, sorry. Memorize. There's no way around it. It's like the unit circle. Know them. No excuse. Do we give them to you on the quiz? No. All right? So learn these. The reciprocal identities, I think we already know. The Pythagorean identities, these are fun. These we use all the time. The Big Daddy. That's why we call it the Big Daddy, because it gets used all the time. All right. If you think about your triangle, you're on your unit circle. This direction is the cosine. This is the sine. Sorry, can't write. This is the sine. If you do the Pythagorean theorem, a squared plus b squared equals c squared, you go cosine squared plus sine squared plus cosine squared equals 1. All right. These are, you also use, well, actually, let's back up to this one. Many times you're going to see that as the cosine squared is equal to 1 minus the sine squared. Or you're going to see the sine squared is equal to 1 minus the cosine squared. So you should recognize those pretty quickly. How did they get these Pythagorean identities? Well, if you take the first one, sine squared plus the cosine squared equals 1. And you divide everything by the cosine squared. Okay, sine squared over cosine squared is the tangent squared. That's your quotient identity. The cosine squared over the cosine squared is 1. 1 over the cosine squared is the secant squared. Okay, so there's one of them. If I go back to the Big Daddy, and you have sine squared plus the cosine squared equals 1, and you divide everything by the sine squared, you get 1 plus the cotangent squared equals the cosecant squared. Okay, so I didn't mean to erase. Dang it, cosine squared theta minus equals 1 minus the sine squared. I wanted to highlight this one. Okay, there's your identities. Know those. Okay, our goal is to simplify things down to something. The problem is usually you don't know the answer. So what am I going to do? Okay, you're going to make substitutions using reciprocal or quotient identities. Use your Pythagorean identities. Change everything into terms of sine and cosine. Usually that's one of the things I do first, but not always. Okay, other algebraic things to do, you can add fractions, multiply by a clever form of 1, factor something out, multiply numerator denominator by the conjugate, distribute, divide. Dividing is the same as multiplying by a reciprocal, cancel common factors. All right, these are more for day 2. Today we're going to do some pretty basic ones. Okay, so simplify these. And one thing about working trig identities. The thing is we grade you on step by step by step. You have to show each step, so it's a lot of writing, and those of you that don't like to write, I'm sorry, I'll apologize now. Second, don't scribble things out that I can't read them. All right, so it tells me to simplify this. So I'm going to make a substitution for the cosecant. Okay, so the sine squared is there. The cosecant I know is 1 over the sine of, oh, that's not squared, sorry. 1 over the sine of theta. And these, I'm going to very lightly cross them out like that, and I end up with 1. You'll notice I didn't do this, because now I can't read it, and I have no idea if you did it right or wrong, or did you copy somebody else's, blah, 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 all those silly things. So when you cross them out lightly, times 1 over the sine of theta. You can, since we got color, you can always do this, and then I can read what you wrote, okay? Good thing. All right. This is the same thing. You'll notice I didn't cross this out and replace it with 1 over cosine. No, you have to show each step. Sorry. Lots of writing. I told you that. All right. So here we are. You have the cosine times 1 over the cosine. Change colors. Shoop, shoop. And you're left with 1. Okay. Tangent, cotangent. Wow, let's see. The same thing. I'll probably use a reciprocal. So I have tan of theta times 1 over the tan of theta. Change colors. Whoop. And I'm left with 1. Okay. These are Pythagorean identities. This is sine squared, cosine squared. How would I know that? Because I've got them memorized. Okay. This is the tangent squared. This is what? -1? Ooh, I don't know. I'll have to come back to that one. Is this the cotangent squared? So what are these? Are the answers up here? Ooh, I don't know. Well, let's work one, okay? Well, I know I can replace the secant squared with 1 plus the tangent squared, right? This is 1 plus the tangent squared minus the tangent squared. And you get 1. Oh, nifty in that. So this is the same as 1 plus the cotangent squared minus the cotangent squared. And you're left with 1. Oh, good things, people. All right, I want you to do these. Those I'm not going to teach on the lesson. If you want to know them, come to the Zoom meeting. Okay, here's some real basic simplifying. You'll notice you'll show every step. So I have the sine of x. The cotangent is the cosine x over the sine of x. Now I can cross this one out, and I'm left with the cosine. And that's your answer. Okay. This one, I'm going to put them all in terms of sine and cosine. So I have the sine of x. The secant is 1 over the cosine. The cotangent is cosine x over the sine of x. I can cross things out, and I'm left with 1. Okay. All right, so 1 plus the tangent squared is the secant squared. Oh, of x, sorry. I'm trying to keep the same thing. X's or thetas. All right, then you can replace the secant squared with 1 over the cosine squared. Then I can cross out, oh, I didn't know there were those colors. Why didn't somebody tell me that? Let's do lavender. This crosses with that and that with that. It's how long in the school year, and I just learned that? Oh. So I'm left, sorry, I go back to blue. Dang, go back to blue. 1 over the cosine, and 1 over the cosine is the secant. Okay, so I had 1 step, 2 steps, 3 steps, 4 steps. I showed them all. I didn't cross anything out. You went sequential. It works better to go down the page. Okay? All right. Put them in terms of sine and cosine. So this is 1 over the sine of x. This is the sine of x over the cosine of x. So that was step 1. I can cross this out and this out. And I'm left with 1 over the cosine of x, which is equal to the secant of x. Is that the only way to do it? No. Okay, that's why it's important to show your steps. Okay, these get a little harder. Sometimes it tells you, you'll notice the directions. These say simplify, which means cross out as many things as you can. Usually you end up with one term, but you don't always. All right, these it says prove the trig identities. Only one operation per step. And the other thing I'm going to add in here, work only one side. Okay, you don't get to work both sides of the equation. Pick one. But the nice thing is they tell you the answer. When I get done making my simplifications, I know what the answer should be. So I usually start with the complicated side. So I've got the sine of theta. The secant is 1 over the cosine of theta. Those multiply together and give you the sine of theta over the cosine of theta, which is equal to the tangent, and I'm done. I just proved my identity. Okay? So here's another one. I take this complicated side, sine squared plus cosine squared is 1. 1 over the cosine squared of theta, and that equals the secant squared of theta, and you're done. Usually they have more than one step. Sometimes they have 9, 10, or 11 steps. Okay? Show your work. This one was a little more complicated. You can get common denominators and add them. First, I changed everything to sine and cosine. So this one becomes 1 over the cosine times 1 over the cosine minus the tangent is sine over cosine. The cotangent is cosine over sine, but you're multiplying by the reciprocal. So the reciprocal is the sine of theta, no, the sine of theta over the cosine of theta. Okay, so this is the reciprocal of that. And that's okay. And so now this is 1 over cosine squared minus sine squared over cosine squared. I have fractions that have common denominators, so I combine the top. 1 minus the sine squared is equal to the cosine squared. The cosine squared over the cosine squared is equal to 1. Booyah. Okay. Alrighty. This is 1 over the cosine. Sine over cosine times 1 over the, no, times the sine, sorry. Times the sine of theta over 1. So I get 1 over the cosine minus sine squared over the cosine, which is 1 minus the sine squared over the cosine. All right, so now I've got the cosine squared. Dang it. Cosine squared over cosine. I can simplify. One of those goes with one of those, and I'm left with just the cosine on top. And that's what I needed. This one was tricky. I had to work on this one for a minute. Okay? Because I know this is the secant squared. So I have 1 minus the tangent squared over the secant squared. And then I got stuck because I didn't know what to do with that. And then I said, oh, I'm going to separate them into separate fractions. So I have 1 over the secant squared, a theta, minus the tan squared. Oop, dang it. Tan squared over the secant squared. Well, 1 over the secant squared is the cosine squared. So I'm heading in the right direction. That's what I need to get when I'm done. This, I'm going to turn them in terms of sine and cosine. So I have the sine squared over the cosine squared. The secant is 1 over cosine, so that's the reciprocal. It's cosine squared over 1. Now I can simplify. These guys cross out. And I'm back to cosine squared theta minus sine squared theta. And you're like, oh, that's 1. No, it has to be a plus. And that's not what I want for an answer anyway. It's got to have a cosine squared. So using the Pythagorean identity, I can change the sine squared into 1 minus the cosine squared. Distribute your negative, and you get cosine squared of theta minus 1 plus the cosine squared of theta. And that's equal to 2 cosine squared theta minus 1. And that's what I was supposed to get. Whoop, whoop, whoop. I did it. All right, identities are fun. Practice, practice, practice. Is there more than one way to solve them? Yes. Do I need to show all my steps? Yes. Can I cross out so nobody can read it? No. All right, enjoy those colors. Talk to you later.